Okay, P6 is rational expressions, and this is day 1. So in this video, we're going to specify numbers that must be excluded from the domain of a rational expression. We're going to simplify rational expressions, we're going to multiply rational expressions, and divide rational expressions. So what is a rational expression? It says a rational expression is a quotient of two polynomials. What's a quotient? It means it's a fraction. So rational is fractional. So anytime you see rational, you know it's going to have a fraction in it. And the two polynomials, well, that's what we were studying when we were factoring, like 2x plus 4, or the x squared plus 2x plus 1, or just the number 7, even as a polynomial. All right, the set of real numbers for which algebraic expression is defined is the domain of the expression. Because rational expressions indicate division, and division by 0 is undefined, we must exclude numbers from a rational expression's domain that make the denominator 0. So what that means is if it tells us to exclude the numbers that are excluded, then what we're going to do is we're going to set our denominator equal to 0 and solve for x. All right, so if we're looking for the numbers that we must exclude from the domain, then we're going to set our denominator, which is the bottom of the fraction, equal to 0 and solve for x. It does not include anything of the numerator. So when we're looking for the excluded values, we do not use the numerator. All right, so example 1 here says find all the numbers that must be excluded from the domain of this rational expression. Well, we're looking only for those excluded numbers. So remember, we said that's where our denominator is equal to 0. So in this case, it's going to be where x squared minus 5x minus 14 is equal to 0. Well, we're going to have to factor that left side of the equation. So check. Does it have a greatest common factor? It does not. How many terms? 3. Simple or alien? Simple. So we know our first two terms, we're going to multiply to be x squared. So it's x and x. And our last two terms here have to multiply to 14, but also, remember, read it backwards. They have to subtract to 5. So they got to multiply to 14 and subtract to 5. Well, here's my numbers that multiply to 14, and 7 minus 2 is 5. Bigger number first. Bring down that first sign. And a negative 7 times what kind of 2 would give me a negative 14? A positive 2. So I can't factor any further. So now I'm going to set each one of these individually equal to 0 and solve. So x minus 7 equals 0. X plus 2 equals 0. Add the 7. So x equals 7. Subtract the 2. So x equals negative 2. And so these are the two numbers that our x value has to be excluded. So what that means, it can be any number except 7 or negative 2. To simplify a rational expression, it says a rational expression is simplified if its numerator and denominator have no common factors other than 1 or negative 1. The following procedure can be used to simplify rational expressions. We're going to factor the numerator and the denominator completely, and then divide both the numerator and the denominator by any common factors. So let's try this. So it says the first thing we're going to do is we're going to factor the numerator and the denominator. So I'm going to look at this x squared minus 1. Does it have a greatest common factor? No. Two terms, difference. Difference of squares or cubes? A difference of squares. So the square root of x squared is x. The square root of 1 is 1. And if you need to, remember, look back at the formula back in, I think it was P5 day 2 that we did this. It'll tell you that it's a plus b times a minus b. Can't factor either one of those any further, so I'm going to rewrite that as my numerator. Now we're going to factor the denominator, x squared plus 2x plus 1. No greatest common factor, 3 terms, simple. So we know it's going to be x and x at the front to give us that x squared. And then we're looking for two numbers. They're going to multiply to 1 and read it backwards. Also add to 2. So it's going to multiply to 1 and add to 2. Well, there's only 1 and 1. 1 plus 1 is 2. Bigger number first. Bring down the first sign. Positive 1 times what kind of 1 will give us a positive 1? A positive. Can't factor those any further, so I'm going to put this in my denominator position. All right. Now, if anything is the same on top and bottom, we can cancel them. And so I see I have an x plus 1 on top, and I have an x plus 1 on bottom. Actually, I have two x plus 1 on bottoms, but it's a 1-for-1 deal. If I only take one of them out of the top, I can only take one out of the bottom. Okay, so we're left with x minus 1 on top over x plus 1 on top. We can't simplify that any further because the minus and the plus signs are like super glue, so that x and 1 are super glued together on the top and the bottom, but they're not exactly the same. One's a plus, one's a minus, so we can't cancel them. So therefore, there's our solution. When we're multiplying rational expressions, it starts out the same way. We're going to factor all numerators and denominators completely, and then we're actually going to cancel anything that's on top and bottom. Because when you multiply fractions, remember, you multiply straight across. So if I have like A over B times C over D, we multiply straight across, we got AC over BD. So if anything was the same on top and bottom, we can cancel. Doesn't matter which fraction it's by. It's like it's one big happy fraction when you're multiplying. All right, so we're going to go through here. We're multiplying, but we've got a bunch of stuff that we need to factor. And while the next slide is empty, so if you need more room, you've got room there, okay? So I've got two fractions being multiplied, so I'm just going to set that up here, two fractions being multiplied. And let's go through and let's factor the individual pieces. So the first numerator is x plus 3. Can I do anything with that? I cannot, so I'm just going to bring it over here. Its denominator is x squared minus 4. Well, no greatest common factor, two terms difference, it's a difference of squares. So the square root of x squared is x, square root of 4 is 2. So when we factor, we get x plus 2 times x minus 2. And so I'm going to put that for the first denominator. Then my second numerator, x squared minus x minus 6. No greatest common factor, three terms, simple. So we know it's going to be x and x to give us that x squared. And then my last two numbers here have to multiply to 6, and they're going to subtract to 1. So multiply to 6, subtract to 1. Well, that would be, what, 2 times 3? Bigger number first. Bring down that first sign. And negative 3 times what kind of 2 will give me a negative 6, a positive 2. That's factored completely, so I'm going to bring that over. That's what x minus 3 times x plus 2. And then that last denominator, x squared plus 6x plus 9. No greatest common factor, three terms, simple. To open my parentheses, I know I need my first one to multiply to x squared, so x and x. My last numbers here are going to have to multiply to 9 and add to 6. So multiply to 9 and add to 6. That's what, 1 times 9 or 3 times 3? 3 times 3. Bigger number first, bring down that first sign. Positive 3 times what kind of 3 gives me a positive 9? Positive. Can't factor it any further, so we're going to just bring that over. All right, now because this is multiplying, it's like we got one big happy fraction here. So anything that's on top and bottom can cancel. And this first x plus 3, it wasn't in parentheses, but it could be. It's the same thing. All right, so I see an x plus 3 and an x plus 3. I see an x plus 2 and an x plus 2. I don't think I see anything else, so I'm going to bring down what I've got. On top, I have x minus 3. Over on bottom, we've got x minus 2 times x plus 3. And so nothing else cancels. Nothing's the same on top and bottom. So this could be a solution. But be careful because sometimes they multiply that denominator part together because there's more than one factor there. So they could have put that it was going to be x minus 3 over, and they would have come over and did like the box or foil to that x minus 2 and that x plus 3. And they got x squared minus 2x positive 3x, and negative 6. So they would have got x squared, 3x minus 2x is x, and then minus 6. So either one of these would be correct answers. All right, then dividing rational expression. Since the quotient of two rational expressions is a product of the first expression and the multiplicative inverse or reciprocal of the second expression. The reciprocal is found by interchanging the numerator and the denominator. Thus, we find the quotient of two rational expressions by inverting the divisor and multiplying. Blah, 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 right? All right, so hopefully you remember keep it, change it, flip it. KCF. That's how we're going to divide fractions. You're going to keep the first fraction. You're going to change the sign from divide to multiply, and then you're going to flip the last fraction. Keep it, change it, flip it. And then you'll be multiplying, so it'll be just like what we had done before. All right, so here we go. We're going to divide these two fractions. So first thing I'm going to do is go ahead and do, first thing I'm going to do is actually go ahead and do my keep it, change it, flip it. So keep the first one, so x squared minus 2x plus 1 over x cubed plus x. Change it from divide to multiply, and then flip it. So this 3x squared plus 3 is going to be over the x squared plus x minus 2. All right, so now we're going to go do a bunch of factoring. So I set up my two fractions with my multiplication in between. And let's go factor that first numerator. So it's x squared minus 2x plus 1. No greatest common factor. 3 terms. Simple. So we know our first terms have to multiply to x squared. So it's going to be x and x. Our last two numbers have to multiply to 1, and they got to add to 2. So what multiplies to 1 but adds to 2? It's 1 times 1. Bigger number first, bring down the first sign. Negative 1 times what kind of 1 gives me a positive 1? Well, a negative. Can't factor those any further, so I'm going to put those in that first numerator. All right, now I'm going to factor the first denominator. So it's x cubed plus x. That does have a greatest common factor of x, so we're going to divide it out. And that leaves us with x squared plus 1. I can't factor that any further, guys. That's a sum of squares. There is no formula for it. It is prime. So we're just going to write x times x plus 1 in the denominator. Now in the second fraction, let's do its numerator, which is now 3x squared plus 3. It has a greatest common factor of 3, so we're going to divide it out. And that gives us x squared plus 1. Again, that's a sum of squares, so we can't do anything with it. It's prime, so we're done factoring, so bring it over. And then we got to factor that last one. The last denominator there is x squared plus x minus 2. No greatest common factor, 3 terms, simple. We know our first terms have to multiply to give me x squared, so x and x. The last two numbers here have to multiply to 2 and read it backwards, subtract to 1. So you got to multiply to 2 and subtract to 1. Well, that's just 1 times 2, because 2 minus 1 is 1. Bigger number first, bring down that first sign. Positive 2 times what kind of 1 gives me a negative 2? A negative. Can't factor that any further, so bring it over. So x plus 2 times x minus 1. All right, now remember, because we're multiplying, it's really like we've got one big happy fraction here. So anything that's on top and bottom can cancel. Be careful, I have a typo here. I don't know, I have a mistake. That was supposed to be x squared plus 1 there. All right, so let's see. I see an x minus 1. I see an x squared plus 1. Let's write what we got left. So I have an x minus 1 and a 3. Now 3 is a single term, so bring it to the front. It doesn't have an x or anything else connected with a plus or minus, I'll call them single terms, and we put the single terms at the front. And then on the bottom, I have a x as a single term, and then I have that x plus 2. So check again, does anything cancel? It does not. So this could be our answer, or they could say, well, what if we distribute? So I'd have 3x minus 3 on top, and x squared plus 2x on bottom. Either one of these are perfectly acceptable. Okay, and that's simplifying, multiplying, and dividing rational expressions.